Hello everyone, I am Harshita KM from Sri Venkateshwara College of Engineering, currently studying 6th in Department of Computer Science and Engineering. Today I am going to present the topic on how to generate the object code using SIC source program. Basically, this is a SIC program which consists of label, opcodes, operands, and the addresses of these opcodes are written in this table. So in the next step, we need to know the location and also the format for these opcodes. So moving to the format section, SIC consists of 4 different formats. It is of type format 1, format 2, format 3 and format 4, where the format 1 is of 1 byte and it consists of only the opcode which is made up of 8 bits. And then format 2 consists of 2 byte where opcode is made of 8 bits and the rest 8 bits are divided into 2 registers of type 4 bits and 4 bits. And then format 3 consists of 3 byte where the opcode is divided into 6 bits. Rest of all the flags consist of 1 bit each, and at last the displacement consists of 12 bits which stores the address of this format. And the last format is format 4. It consists of 4 bytes where the opcode is of 8 bits and rest of all the flags are made of 1 bit and the address is of 20 bits. So by using these formats, we need to generate the format and also the location for this opcode. The first opcode is clear X, where the clear X consists of only one register, that is X, so it is in the type format 2. And the LDT is of format 3 because it doesn't consist of any registers and also there is no plus symbol in front of LDT, so we are considering LDT as a format 3. In the same way, TD, JQ, LDCH, WD, JLT and RSub are of type format 3 and TIXR consists of one register which is in format 2. So by considering these formats, we need to add the location one by one. So the starting location is 405D. By adding 2 for the address of 405D, we'll get 405F. And then by adding the address 3 to the 405F, we'll get 4062. The rest of all the locations are just made up by adding these formats. So let's see how to write the object code for first opcode, that is clear X. The value for clear is B4 and the value of X is 1. The opcode is made of 8 bits, so we are writing the binary value of B as 011 and the 4 is 0100. As it consists of only one register, that is X, so we are writing the X value as 0001 and it doesn't consist of any other registers, while writing it as 4 zeros. So the object code for clear X is B410. And then next moving to the opcode LDT length. Here the value of LDT is 74 and the value of length is 4033 and it's of type format 3. Here opcode is of only 6 bits, so we are writing initially 7 in the form of 4 bits, that is 0111, and the next 2 bits is filled by the value of 4, so 01. Here it doesn't consist of any plus, hash or any other symbols. We are writing N and I value as 1 as there is no presence of any register, so X value is 0 and the base register value is 0. Here the program counter register incremented to 1 because in the displacement the value of displacement can be written in only form of 12 bits. The length value is of 4033 which is of type 20 bits, we can't fit the 4033 value into displacement, so we need to take the hexadecimal value of length, that is 4033, and then we need to subtract it with the next address, that is 4062. By subtracting these two values, we'll get FD4 as an extra decimal value, so we are writing in displacement address. So after doing all this, we need to divide these bits into 4-bit form. So after dividing this address into 4-bit form, we'll get 772 FD4 as an object code for LDT length. And then next, so moving to next opcode, that is TD output, which is of type format 3. Here the value of TD is E0 and the output value is 4076. The initial 4 bits of opcode is written in the binary value of E, that is 1110, and the next value of 0 is written in 2-bit form. As there is no plus or any other symbols, the N and I value is 11, and the index register is 0, the base register is 0. Again the program counter is 1 because in the displacement we need to write output value in 12-bit form, but the value of output is 4076, which is of 20-bit format, so we can't fit the value of 4076 into displacement, so we need to take the value of output and then we need to subtract it with the next address. By subtracting, we'll get the 011 as hexadecimal address, and then we can place the 011 in displacement. So by dividing these address into 4-bit format, then again we'll get the object code as E32011. Then next, moving to JQW loop, the value of JQ is 30 and the W loop value is 4062. So the initial 4 bits of opcode is of value 3, that is 0011, and the next 2 bits are 00. Here again N and I are 11, then X is 0, B is 0, program counter is 1 because the value of W loop is 4062. Again it is of 20 bits which can't be fit into displacement, so we need to subtract the W loop address with its next address. We'll get the hexadecimal value as FFA. Again dividing this address into 4-bit format, we'll get 332 FFA as a object code. And then next, moving to the opcode LDCH buffer X. Here it is of format 3, where the first 4 bits of opcode is written with the value 5, that is 0101, and 0 is written in 2-bit form. Again the value of N and I is 1. Here the value of X is 1 because the buffer contains X register, so we are mentioning X as 1. Again B is 0. The program counter is 1 because the displacement address is incremented by subtracting the value of buffer and the next address, so here the program counter value is incremented, and again dividing this address into 4 bits, we'll get 53AFC8 as a object code for LDCH buffer X. Then next, moving to WT output, which is of format 3. Again here the opcode is of 6 bits, where the first 4 bits are written as binary value of D, and then next 2 bits are C. The value of N and I is 11, and there is no presence of any register, so 0 as X, B as 0. Again we are subtracting the output value with the next address, so we are getting program counter as 1, so the displacement is 008. The object code for WT output is DF2008. So in the same way we are solving for this TIXR and JLT. At last, the R sub is of format 3 type, where the value of R sub is 4F. So you are writing 4F and 4 zeros in format 3 form, and then byte address is byte 05 consists of one opcode, that is we can return in the format 1. So after generating all these object codes, we are writing the object code for each opcode, and then at last we need to write the object program where head stands for head record. The name of the program is written here, that is start. The initial value of the opcode is start, so the initial value for the same opcode is 0050 where 405D is in 4 bits, but we need to write the starting address in 6-bit form, so 00405D. And the next one is text record, where we need to mention all the object codes what we have generated. So and at last we need to write the end record. The value of end record is the starting address of the opcode, so it is also again is the format of 6 bits, so we need to write the starting address 405D. Additional 2 bits are added to the starting address. Thank you.